output voltage is 180 degree, not 0 degree. So this would be false also. This one is clear, right?
Yes.
Okay. So for the now the third question, a network consists of DC voltages, resistor and capacitor. The DC current flowing through every capacitor in the circuit would be 0. This one would be true because if you have remembered, so we have the formula is IC dVc dt. In dVc dt, and if Vc is constant, so we will get this whole thing as 0, right? The derivation would be 0 fit. So the current passing through would be 0. So this is true. Clear?
Yes, ma'am.
Okay. So in this question, we are given the RC circuit A and B, and it is said that in the circuit A, we have R1 and C1, and in the circuit B, we have R2 and C2. And they said that R1 is greater than R2 and C1 is greater than C2. So the time would be taken more by B. It is written here, but this will not be true because we can
Time
find
taken
time
same.
not same because we have R1 high, R1 and C1 high. So time taken by circuit A would be uh, R1 into C1. We can find it from the time constant formula also. No? So RC. So RC would be greater because, wait, first we can write time taken by circuit B would be R2 C2. Circuit this one would be higher because we have R1 big and also C1 is larger. So this whole thing would be larger, right?
Yes.
And this R2 and C2 would be less. So which circuit would take time more?
Um. First A.
Yes, because RC would turn out to be larger number because R1 is higher also, C1 is higher also. And in this question, it is given that the circuit A is taking time less and B is taking more. So this would be false. Is it clear?
Yes.
Okay, so for the sixth question, it is given that we have two subnetworks N1 and N2 where we have these three resistors where two are 4 ohms and one is 2 ohm, and we are given the voltage across it, and we have to find this Vx. So if you see in this question, in N1 side we have positive side, right? And here in N2 side we have negative side. So current will pass in the direction N1 to N2. Okay, so whenever we have something, so it will be like we have circuit. So if current is going here, so it will be back also. So from the KCL we can write that the current flowing through this I1, I2, I3 would be equals to 0, right?
In the question is mentioned that we had to find the delivered or absorbed current.
No, we
Power.
have to find this Vx.
Because I got 10 watts positive because it is entering from positive.
No, we have to just simply find this Vx.
Okay.
So when we do I1 plus I2 plus I3, what is V1, R1, V2, R2, V3, R3. So what is V1? We'll take this here. 8 volt divided by 4 ohm. What is V2? Tell me.
2 and 3
Two,
amperes. Total 5 amperes we get across the both.
Don't tell
four,
the whole thing.
four,
Yes. What
Due
is
to the 8
V3?
by 4 we got 2
VX,
amperes, and by
Yes.
12 by 4 we got 3 amperes.
two,
What is I3?
2 ohm,
Yes. Yes. Now we can write this as 4 to the 8 or 3 to 12. This is 5 plus Vx by 2 is equals to 0. Right?
Yes.
Now we can do what? Vx is equals to minus 5, and from here we will get Vx is equals to minus 10. Right? Got it?
-10. Okay.
You got this now?
yes,
Yes, ma'am. I write that positive 10 watts. 10.
You just have to add this current because it is flowing from positive to negative terminal. You don't have
Yes.
to look for the absorbed sign and all. Okay, so now we have this question. Just copy paste it. So tell me what we will do here.
First, we will find the equivalent resistance,
Hmm.
then find the value of current.
We can use the voltage divider rule.
Yes. So the simpler way would be the voltage divider. This type of question was there in any activity also. So
Okay.
first we can do is uh, calculate them in parallel. So what would be the parallel? 8.
8 and 12 ohm.
Hmm. What you will get from here?
24 by 5. I mean,
It will turn out to be 4.8.
Yeah, 4.8.
Okay. So now, how we can redraw this? 4 ohm. This would be 4.8
Yeah.
and 4 ohm and 6 volt. And
We will
if you
use
see,
voltage dividing rule here.
yes. So this is V naught again. So we can simply found this V naught. And if you see, if we take 0 volt here, it would be 0 volt here also, and here we will have minus 6 volt. So the voltage we will write 4.8 into minus 6 volt divided by 4.8 plus 4. What you will get from here? You will get 3.27
Yes.
and the minus with it. Did you
Minus
get
because the voltage because of the source is from opposite side, like positive terminal.
Yes, and even if you just try to find taking 6 volt here, then you will get 4.8 in positive, but the direction of V naught is given plus and negative, so you have to like minus.
Yes.
Okay, so let's go to the next question. So here we have to find the cutoff frequency. And see one thing here that the unit is given in radian second, so you will not use the formula f is equals to 1 by 2 pi rc, but you will use omega is equals to 1 by rc. So what is r is 6.8 kilo ohm and c is 0.05 microfarad. So omega is equals to 1 by 6.8 kilo ohm into 0.05 microfarad. Can you do the calculation and tell me? 1 divided 6. So we are getting 2.94117 and into 10 to the power 3. So we can multiply this now. 2.4 1 1.76. We can remove this because we have to just write it till second decimal point. Okay.
It is mandatory to write that point 17.
See, this was MSQ now, so you can write it. And always it would be written here, even if it is an integer question, that you have to truncate it to two decimal points.
Okay, and rounding off. But here we had to maintain.
Then no answer will match, no? See,
Okay.
clear?
Yes.
Okay. So now for this question. So what we will do here?
We will first simplify the circuit using that parallel and series combination of resistors, and
Yes.
then we will find the current across the branches using the current dividing rule.
Yes. So this is in series, so we can just,
Series and parallel with 14.
yes, yes. Give me time to write na.
Okay.
So 5 plus 9 would be 14 ohm. Okay. So
Yes.
again, what we can do is, if I just do it in one figure, is that a problem? No.
No, not for me, but
What about others?
No, ma'am.
Okay then. So now this will be in parallel with this 14 ohm. So we can write 14 ohm and this parallel
it,
14 ohm. So this will be 14 ohm by 2, which is 7 ohm, right?
it is series with 11 ohm.
Yes. Now this thing will be in series. I think it's getting messy. We can redraw. This is 44. This is 13. This is 18. This is 11. This is 7. And this one is 22. 18 ohm. This is I. This is 13 ohm. And this is 11 ohm. Now it is all good. So we can write this 11 ohm and 7 ohm in series. So it will be,
18 ohm,
yes.
and it is parallel with the 18 ohm, so we got half of it.
Hmm. So we will get
9 ohm.
9 ohm. Now we can again write this.
9 ohm is in series with 13 ohm.
I want to redraw this because from here we can do it simply.
Yes.
9 ohm, 13 ohm, and 22 ohm. Okay, 44 volt. So this 13 ohm and 9 ohm is in series. So
We
what
got
we will get?
22 ohm. 22 ohm.
Yes. And if we do this 22 ohm and this 22 ohm in parallel, then we will get,
We got 11 ohm,
huh. So this is
and the
our
current
R
we got
equivalent.
is, yeah, 4 amperes.
Yes. So now we can write current as I is equals to V upon R. V is 44 volt divided by 11 ohm. So we will get 4 ampere. Okay. So now we can do one thing, that if you see this, it will be like this.
22 ohm and
20.
22 ohm is in parallel. first.
So, and
Current
current
divide
is flowing through
equally
here.
divided in both. So we got 2 amperes in each.
Yes. So is this thing clear with everyone? Na? This will get divided. With everyone, is this clear?
Yes.
So this will get divided in 2 ampere and 2 ampere. And again, we can draw this whole thing here. So it would be like 22 ohm, 22 ohm, and here we will have 18 ohm, and again in parallel we will have 18 ohm. Till here it is clear. And we had to find the current in this 18 ohm branch. Clear?
Yes.
Okay, so now this 2 ampere will again get distributed in equal parts because we have 18 ohm here and
Yeah.
18 ohm here.
18.
So I would be what?
Yes.
1 ampere.
1
Is this,
ampere and 1 ampere divide equally in that both.
it's, someone was saying something? This one is clear? Mm-hmm. Is this clear to everyone till now?
Yes, ma'am.
Okay. So now for this 10th question. See, from the circuit, in this question we are asked to write the time constant, and we are given the R value, which is 10 kilo ohm, and C value, which is 100 microfarad.
-1 over 1.
So what is time constant? RC. R is 10 kilo ohm. We can write this as 10 into 10 to the power 3, and C is 100 microfarad. We can write this micro as 10. So this whole thing will become 10 to the power 6, and we have this 10 to the power minus 6. So this and this will be gone, and we will get 1, only 1 second. Is this clear? Okay. Now we can move to this 11. We are given the V input, which is 200 millivolt, and V output, which is 2 volt. Now we have to find the gain or amplifying factor. So what's the formula? That V in, the gain is equals to V out. Now we can write this gain as V out divided by V in. So this V out would be 2, and this is 200, 10 to the power minus 3. So when you solve it, you will get 10. Stop me whenever you have any doubt. Okay.
Ma'am, we just multiply with the amplitude factor,
Uh,
amplification factor.
we have to find the amplification factor.
Okay.
To find the V output, you will multiply this amplification factor in V input.
Yes. And output
Now
is
we have,
given, so we had to find the amplification factor. Okay.
yes.
Okay.
So we have this circuit, and we have to find the power delivered by 2 ampere.
So
So
we had
first we
to use
can
the superposition method here.
uh, uh, okay, any other solution which you can
Yeah,
apply here?
we can find the nodal voltage.
So if you apply this nodal analysis, so that would be easier.
Yes.
Also you can do it with the superposition also, but I'm going to solve it with KCL. Okay, you can try once with the superposition also. So by KCL, this is the node. We can write it here. This is 0 volt. This will be 5 volt. This would be 0 volt, and this would be minus 1 volt. So this is VA minus 5 divided by 1 plus VA minus 1 divided by 3 is equals to this current is upcoming, so it would be positive.
Yes. Is equals to 2
Now
ampere.
we can multiply 3 here. 3 VA minus 5 divided by 3 VA plus 1 divided by 3. This would be 3. If
Now,
you
why we
solve this
multiply with 3? Uh,
to make the denominator same,
okay.
like LCM. So this will be 3VA minus 5 plus VA plus 1. And we can do one thing, this 3 would go here. So it would be 2 into 3. So now after doing this, we can write this VA, 4VA minus 4. 3 to just 6. We can write 4VA. Did I do something wrong? Yes, I think so. VA minus 5. VA plus 1 by 3. This is 2. 3VA. Huh. Here. I forgot to multiply 3. Yes. So this we will get here 4VA minus 14 is this 6. So when you solve this, you will get VA is equals to 5 volt.
And ma'am, we did not multiply that second VA plus 1 volt with the 3.
We did see 3VA.
Yeah, but
Then
second after the
where
plus sign.
this
After the plus sign with the VA and 1, did not multiply.
we did. That's why it became plus 1. Na? This was also minus 1. Minus minus plus
Plus.
1.
Okay.
And we took the LCM here. So
Yes.
this 3 went on this other side, and it got multiplied to 2,
Yeah, we got
and we
6.
got this thing.
Yes.
Okay, so give me a minute. Okay, we can continue. So if you see here, now we got this VAS 5 volt. So here we have 5 volt also. Here we have 5 volt also. So this thing will become short circuit. this is short circuit means this is just this. So whatever would be here, we can write it like this VA. Now we are applying this KCL here from here. We can write this VA. This would be plus minus. We already know the sign 2 ampere. So we can find the voltage across this 2 ohm. This would be 2 ohm into 2 ampere
Yeah, how to
plus.
find my voltage across the 2 ohm?
That we are telling me. Or
Okay,
we can, instead of here, we can go from here. So this would be plus minus. I'm starting from here, okay? So
okay.
this is 4x minus 2 into 2. This is 2 ohm into 2 ampere plus 5 is equals to 0. Right? Because this thing got short circuited. So the whole thing should be equals to 0. So now we can write Vx minus. Did I do something?
No, you are using superposition now?
No, it's not superposition. I was doing KCL.
Okay.
Hmm, Give me a minute. Okay. So this whole thing should be equal to 0, right? Because this got short circuited and this will short circuited. So means in a way this is VA and this is also VA. So this whole thing should be the voltage across this should be 0. So we can write it like the voltage across this 2 ohm is 4 volt. So whatever the voltage is left would be here. So we can write this Vx is equals to this 5 minus 4 volt. Okay. So this would be 1 volt Vx. And now we have to find what we have to find. We have to find the power delivered by this. So the voltage is in the same direction and the 2 ampere is in the same direction. So power delivered by this would be 1 volt into 2 ampere, which would be 2 watt. Is it clear? Hmm. Am I audible?
Yes, ma'am.
Okay. So let's continue with this 13th question. We have to finish it in 20 minutes. Okay. So can you speak because I can't see the chats? Okay. So what we have to find? We have to find this V naught. How do we find that? Anyone? Any answers? Too much silence. Yes, but see in that question, it should be 0. This whole thing because this is getting short circuited. Uh, Here I told na this VA and this thing whole is getting short circuited. So the whatever the voltage is here, it should be here also. So how we can make it when the voltage in the whole thing would be same to this? Then we can say it.
Ma'am, then there will be no flow of current, no?
That what we have to do, na? Because this is short circuited. So if you apply the things we do, that's then it would be VA. Here it would be VA also, and here it would be VA also. So there should be the whole current would be flowing through this, and the short circuit where it's the short circuit. Okay.
Yes,
So we have
ma'am.
to make something that the whole voltage would be equal to this, and it will get short circuited. Is it clear?
Yes, ma'am.
Okay then. How do we solve this question?
Using superposition principle.
There is one another easy way. What that can be? Okay. You
Ma'am,
can try with yes, KCL. Maybe superposition would be easy for some peoples, but I always prefer KCL. So I'm gonna do with KCL. Okay. So I'm taking this node as VA, and here we will have plus 10 volt. Now we can write what would be the equation of this? Tell me. I want answers. So this would be VA minus 0 volt divided by 3 volt. You all have to be little interactive. Otherwise, class doesn't seem fun. It's just a boring thing. It's just VA minus 10 volt, and this 2 ampere is coming, so it would be 2 ampere like this. Can you please say it instead of writing in chats? So now we will take the LCM. So 2 VA, we will just write it here directly. 2 into 2, 3, 2 VA should be 3 VA minus 30, and LCM would be 6. Is it clear?
Yes, ma'am.
Okay, so we can write this 5 volt, and this would be 30. We can do this multiply here, so it would be 6 to the 12. Now we can write this VA as 12 plus 30 divided by 5. Can you do the calculation? That would be our answer. 8.4.
We are using KVL. KCL.
We are using KVL.
Okay.
Did I say
What
KCL?
superposition? It is easy, na,
KCL.
ma'am, with
Wait,
superposition.
we are using KCL.
Yeah, but it is easy with superposition. Like,
Yes, you can try, but for me, this KCL always seems pretty easy. Like everyone
okay,
has their favorites now, so for me, KCL is favorite.
okay.
You can try with superposition also. You will get the same answer.
Yes.
Is this clear with everyone? You have questions?
Yes, ma'am.
Okay. So let's solve this one. Tell me what we can do here.
First, what to find in this question? Power in
Uh,
watts by the
we
source
have
in
to
watt.
find the supplied voltage.
Yes,
Uh, wait.
we will find the equivalent resistance like 1 ohm and 1 ohm is in series like a 2 ohm.
Mhm. Wait, why
And
is this
there
not
are
getting?
three sources. There are two current. First, we will find the equivalent resistance using the superposition method and find if we energize 10 volts only, then what amperes we got and the uh, ampere sources we have.
We have to find the whole thing. Huh? In the circuit, the power by the voltage source.
Yeah,
So we have
so
to
we will
find.
disconnect that current sources na when we use the voltage source.
Huh.
Ananya,
Huh.
one second. Can we go to
Yes, sir.
the yeah question number 12? I guess there is some error that we did. Can we go to the question number 12?
Yes, sir.
Mm. So VA could come out to be 5 volt, right? Okay. So then voltage across this 2 ampere current source would be what? I guess
One.
1 or 9.
One because we have to make it zero. Na? This thing would be short circuited. So
Mm, no.
so whatever the voltage is here, it should be here also.
But we
Mm,
will get some voltage due to the 2 ampere source also, na ma'am.
yeah, yeah, correct, correct. See, if you'll just write a equation, can you write the equation? Let's for example just take it this as a VA, okay? Vx. So it will be minus Vx plus how much? 4 volt, right here. Uh,
Hmm.
plus 4 volt, and here it is how much? 5, right? Plus 5. Okay, so I guess it should be 9 volt. Can you just write one equation and then check it? Not like assume it. Just write the equation one.
This in this loop.
Yeah, just state this wire itself. You start from 0. Okay, just consider this as a 0 volt.
Hmm. Where?
Because I
So
guess the answer will not be 2 volt. That is what I think. No, sorry, 2 what? How many of you have attempted this question?
Yeah, I attempted, sir, but I take the 2 watts. And but sir, I got difficulty to find the voltage across that 2 ohm source
2 watt
because
I
power is
feel,
equals to power is equals to current into voltage. If we got the voltage across 2 ohm, then we just multiply 2 ampere with that. So we got the power.
no, that is fine. But what is the voltage that you are getting across 2 ampere current source?
Yeah, I don't know. I did so many calculations yesterday
Okay.
for that question. Spent too much time on that.
Yeah, I guess whatever Susil is saying is correct. 9 volt will be the voltage across 2 ampere current source.
but sir, this thing is getting short circuited. So this would be 5 volt,
5 volt.
and here it should be 5 volt also. Means whatever would be the calculation here, it should be 5 volt in the whole thing.
And it is the minus 1 volt. So it will be from.
No, 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 no. 1 second, 1 second. Okay, so there is no current in this wire. Okay, uh, current in
Yes.
that doesn't mean this the polarity, the positive side and negative side both will be having the same potential. That can't be possible, right? There is a battery right here, 5 volt
Hmm.
voltage source, right?
Sir,
Uh,
I got one thing yesterday that due to the 5 volt source, we got 0 amperes at a VA.
that is fine. The whole 2 ampere current can flow in this the other circuit, right?
Yes.
Correct. But here you can't assume this as a, so if you'll just ground it below like the negative polarity of Vx, right?
Hmm.
That can be grounded. There is a 5 volt battery, but there is no current in this. Okay, because of
Hmm.
the, because basically there is no current across this 1 ohm resistance. Okay, resistor. Okay, this VA is 5 volt, but you can't take the negative Vx, like the negative quality of Vx also as a 5 volt. I guess that will be 0 volt itself. You can just assume it as an open circuit here, like at 1 ohm, but it will not be like if you open it, the voltage across this wire doesn't came out to be 0 volt, right? It can be some voltage. Are you getting me, Ananya?
Yes, sir.
Yeah, so the voltage across this battery can be 5 volt, but then there is no current across 1 ohm because at VA also you have a 5 volt of potential. Okay.
Yes.
Yeah.
Uh,
Yeah. 2 amperes divide in that 3 ohm and 1 ohm.
Yeah, so this 2 ampere, the whole current will flow in the other
Yes.
circuit. Okay, there won't be any
Yeah.
current in this. Okay,
Sir,
but the
that's why, sir, when I use a superposition method and find a current due to the 5 volt, that I got 3.75 amperes, and not 3.75, 1.75 or 1.5 something, and due to the and remaining current of 2 amperes I got from minus 1 or like 1 volt at
okay,
the VA.
but that is not. See, we just have to know the voltage across this current source. If you are able to know that, you just have to multiply 2 ampere to
Yeah,
get the power.
power is
Okay.
equals to I into V. That
Okay, okay. Right. So only thing, the problem here that is occurring is you can't take the negative, like the polarity, the starting point of this current source also as a zero, like 5 volt. That is not possible. Okay. Otherwise, the whole circuit will break. Right. It's starting from some 5 volt going to 5 volt itself. Then there won't be any current as well. Right?
okay. So
mhm.
can we start solving with a superposition so it will be easy to see what we got?
No, no, no. Superposition will make the thing complex. Okay. What I'm trying to say is, whatever she solved it, can you just go to the solution? I just, yeah,
Huh?
whatever you wrote, Ananya. Yeah. So the solution that she gave till here it is correct. VA came out to be 5 volt. That's fine. But this again, this the point, the below point that you wrote, right, VA, that is not correct. Okay, because there is a potential. Okay, if you have an open circuit, that doesn't mean the open circuit doesn't have the voltage across that space. Like the delta V doesn't came out to be zero if you have an open circuit, right? If you have open wire, right, there can be some potential difference between those two wire. Okay, if you cut a wire, right, in a like electric, like in your home itself, it's not like the voltage across two wire is zero. Okay, it's just that it's open, there won't be any current.
Okay,
Okay.
sir.
Zero current means if you have resistor right here, that means that there is like the potential difference between these 2 points is zero. That's why the current is zero here. Okay, but here 5 volt and there will be a potential difference because there's a battery, right? So uh,
So,
I
sir, we can write this case for this KCL.
yeah. So here it will be 0 volt only. This will be a
Uh,
ground. You can write it from here. You can write the
with
equation here, something like that.
plus minus
Yeah,
4
Vx
amperes,
minus 4, not 4 ampere.
4 volt
Yeah, 4 volt and plus 5.
equals to 5.
Not equal. Yeah, so Vx will be 9 volt. Yeah, that seems correct to me. So the power,
So,
yeah, the power will be 9 times 2. So 18 watt should be the answer. And how many of you got 18 watt? Anybody got it? 18 watt is the correct answer.
Yes.
Got
Yes,
it.
sir.
Yeah. I
Sir,
hope it,
in option also in exam we got 18 watt.
yeah, yeah, 18 would have been the
10
option.
watt
Yeah.
as something. That
Hmm.
type of option was there.
Yeah, yeah, 18 watt was there. Yeah, yeah. There is some error in this PDF. Ananya, I hope I've sent you, like, there is some error in this PDF.
yes, sir.
Okay. Yeah, you can go ahead. Others solutions are fine. Anybody has any doubt on this question? No, right? Okay. Okay, you can go ahead with 14th. 14th.
Okay.
Sir, in that question, sir, that bottom node is 9 volt. That is correct.
Bottom is not 9 volt.
Bottom is
The
0.
volt
We got Vx
Okay.
as 9.
Vx is 9 volt.
Okay.
That's how this 4 volt will be consumed by this 2 ohm resistance, and then 5 volt will be remaining at VA.
Okay, sir.
Okay. Yeah, this is the 14th question. You have to calculate the power supplied by the voltage source, right? This will come out to be zero if you'll just see the current, just see the flow of the current. Okay, you'll come out, you'll know that 1 ampere is coming from this direction in this wire, 2
Yeah,
ampere.
Mm.
So both
yeah.
of them,
There is a 3 ampere total.
yeah, both of them will get added to 3 ampere, right?
Yes, and due to 10 amperes, we got 2.75 amperes. Something. If we just
We,
energize the 10-volt source.
you can do
You can see that.
superposition and KCL again.
Superposition. Yes.
Yeah, no need
If we
of,
use a superposition, then only the four resistance of 1 ohm is in series. So we got 4 ohm resistance.
no need to do anything. See, if you'll just see the current, 1 ampere plus 2 ampere, right? 3 ampere.
Yeah, 3 ampere.
Yeah, the whole 3 ampere will come across this itself. You can see that.
Here.
There won't be any current in this 10 volt that battery. You can see that the 3 ampere comes, 1 ampere will go again at that point, and again 2 amperes comes here. So there won't be any current that will go there. 1 second.
Okay. So you mean the total current is 3 ampere in that circuit?
Yeah, you can see that, right? Again, the 1 ampere will come here and 2 ampere goes there. So
So that means our power is equals to IV. So voltage is 10 volts and
Current
current is
would
3
going
ampere.
be
Then we
is
got 30
0.
watts.
mhm.
30 watt is not in option.
No, 30 watt, no. There is no current here, right?
Okay.
See, the whole 1 ampere and 2 ampere came here, and again the 1 ampere went there, and 2 ampere came back.
Yes.
Yeah,
So there is a zero.
yeah, zero is in the option. Yeah, everybody got that or not? How many of you got this as an answer?
Yes, sir.
Sir, me.
Okay, nice. Yeah, Ananya, you can go ahead. I'll just drop the call. I have got a call. Okay.
Okay, sir.
And how was the paper for everybody? It was an easy paper, right?
Yes, sir.
Yeah,
Okay.
it is easy, but now I am thinking that I did two or three mistakes in questions.
So that happens, no issues. Yeah, but overall the paper was not that difficult, right?
Yes,
Uh,
yes.
yeah, I guess there is only one error. I hope that is in the 15th question. I guess the power delivered would be some plus, and I guess the answer is in minus. So that I'll change it. Yeah, Ananya, you can go ahead. And thank you, everyone. Huh?
Yeah, thank you, sir.
Thank you, sir. So 15th question. We have this. Okay. So in the 15th question, we have to find the total absorbed power.
Yes.
So, how do we find it?
Ma'am, first we will see the direction of the current, and we will find that current is absorbing or delivering. And we will,
Yes, and then we'll add all of them.
yes,
So first we can tell that 2 ampere
we
is
had to find the absorb. Ma'am,
yes. So this 100 volt is doing what? Absorbing or delivering?
Absorbing
absorbing.
Yes. So what would be the power?
1000.
Yes, 1000.
Okay. So this 15 volt is doing what?
Ma'am, like a 10 ampere is coming and 8 amperes is going through the 18 volts. Then the remaining 2 amperes is due
That
to
source is
15 volts.
releasing power.
Yes,
15 volt, right?
Yes, ma'am.
yes,
So how do we write it? What sign would be here?
Minus.
yes,
Yes, because it is delivering, but we have to find absorbing.
yes. It is delivering the power with
So
2
this,
ampere, thir- 30 watt. It is delivering.
okay. So this and the this 80 volt, what it
Is
is doing?
delivering the power of um 600 and 400,
640.
640. Yes,
So we can write this directly also then.
yes,
30 watt. So what we will get?
330.
Yes.
minus 330.
We will get 330. That what sir said just now. That this question answer is given wrong. Sir will
Okay.
fix it.
I also wrote that minus 330. Ma'am, then
What
what
did
will be happen, ma'am? The answer is grading.
answer would be set this 330 because it was in the option. Na?
Yeah, 330. I wrote that I know 330, but positive or negative. And now I'm confused. That
So see, what we have to do is we have to find the absorbed power.
power. Yes, absorb.
So this is already absorbing power.
Yeah.
So this will be in positive.
So absorb is greater. Yes, ma'am. So my answer is positive. Yes, definitely. Like that. Correct.
And this one is delivering power.
Yes.
So we
But
will write
absorb is greater than the deliver.
uh, not the greater and all, but if it is delivering, so we will write absorbing as negative.
Yes. So my
And
positive negative like that now. Like
No, ma'am. I think he's asking about calculation. In calculation, that 1000 watt is positive, and
positive.
overall
Yes.
that will be positive. I think he's asking this.
That
oh,
yeah.
okay.
That's answer.
So this calculation will turn out to be higher. So if you minus them, then it would be positive.
Yes, positive. Positive. I got. Yes, ma'am.
Okay. So here also absorbing power would be negative. Hope it is clear.
Yes, ma'am.
Okay. So now let's move on to the 16th question. And in this question, we have to first find the power absorbed by R1 2 ohm. So we can do it without doing any calculation.
Yes, ma'am. Just absorbing. Seeing that circuit.
Just finding the current.
Yes.
So we have 10 ampere going here and
Yeah.
2 ampere coming here. So what would be the current flowing here?
Ma'am, 10
-8.
ampere is
10
going
ampere.
downwards and 6 amperes gone from it.
Where did you get? Just stay here at this note. 2
Okay.
Ma'am,
ampere. Yes.
yes, ma'am. Continue.
So what would be the current here? It would,
-8.
so we will just write it like this. What you said was correct also.
Yes, ma'am.
So
Um,
this
I said that 6 ampere is going from that 10 ampere source and remaining 4 amperes is going through that 5 volt and opposing that 2 ampere. So it will be minus from that. So I got 2 ampere across it.
okay. So this 2 ampere is going here, and we will get here 4
4
ampere.
ampere.
Yes. So now we have to find the power absorbed by R1 is equals to 2 ohm. Means this one. No, sorry, this one. So the sign would be it's a resistor, so it will always absorb power. So the power absorbed will be 2 ohm into 8 ampere. Change it to black. This would be 16 watt.
No, ma'am. 128, ma'am. IR square.
Oh, sorry.
I square R. I square R.
Yes, yes. So power absorbed would be I square R, which is 8 ampere square into 2. This is 64 into 2. Means we will get 128 watt. Okay. So now we have to find the power delivered by 5 volt. So the current is flowing in this direction also, and 5 volt is in this direction, so it will deliver or absorb.
It will
Deliver.
deliver.
Yes, so delivered power would be by 5 volt, 5 volt into 8 ampere, right?
Yes,
So
ma'am.
it would be 40 watt. Someone asked me one question about this. So is that person here in the meeting? So hope it is clear to them. So now it is asked power absorbed by 4 volt. Absorbed by 4 volt. So here we have this 4 volt. So it is delivering power or absorbing power?
Deliver.
Absorbing.
It is absorbing. So there will be no sign change, and we can write 4 volt 4 into 4 ampere. This would be 16 watt. Clear?
But ma'am, 6 ampere is also in the circuit, na ma'am.
6 ampere is in this different. Here when you will get 6 ampere, so it will divide in two parts. One will go here 2 ampere and one will here, which is 4 ampere.
Okay, and 10 ampere is going downwards, so 8 ampere is going through it, and 2 ampere is going on that side. Then that current,
Then here the current would be 6 ampere, because 4 ampere is coming here and 2 ampere is coming here. So at this node it would be 4 plus 2, 6 ampere.
okay.
Okay. So now we can move on to the next question. This one is clear now to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So now this comes someone's favorite question, which is based on superposition. Okay. So this is 17. Okay. By the way, correct me if I'm doing anything wrong. Okay. Also, you can ask any question. So first we have to do it when the first 1 ampere current source is energized, means this would be energized and this would be de-energized. So let's do this. This is 4. This is 5 ohm, and this will get open circuit, right?
Yes.
So this
So
is,
total 6 ohm and 6 ohm is in parallel.
yes. So the this is 5, this is 2
2
ohm,
ohm,
and this is 4 ohm.
4 ohm. Yes.
And this thing would be in series.
Yeah. So it is 6 ohm and 6 ohm is in parallel.
Yes,
So
and
the
this,
current divide equally to both
huh, and this will
zero
be in
point 0.5
series.
and 0.5. Yes. And according to the direction of that volt and the given polarity, we got.
Yes. So we can just if that thing is clear, so we can simply write directly, or we can redraw it also.
Yes.
So let's just redraw it so that it will be clear for everyone. This is 5, this is 1, and this is 6. Is this okay, or if not, I can redraw this in other way? 5 ohm, and this is 1 ohm, and this is 6 ohm. We have to find the current across this.
Yes. So current equally divides in both
Hmm.
6 ohm, and in a series the current is not divided. So the current across the 5 ohm and 1 ohm is same. That is 0.
Yes. So the current here would be 0.5, and also here it would be 0.5.
Yeah.
So the first current passing through is okay. So here the current passing through would be 0.5,
Yes.
and the answer is 0.5. Okay. And let's just do it taking one direction. We can do this later. Okay. So now we have to do is
Energizing 2 ampere. So
I think I have to stop her. Okay. Hope she stays silent now, so we can study. So now it is, we have to energize this 2 ampere and de-energize this 1 ampere.
yes.
So we can draw this. This is 2 ampere. This is 2 ohm, and this is 1 ohm. This is 5 ohm, and this is 4 ohm.
So it is connected in series, 5 ohm and 4 ohm.
Yes. So
So we
this
got
will become,
9 ohm.
yes,
That
5
1
ohm.
ohm and 2 ohm is in series, so we will got 3 ohm.
Yes. And the current passing through this 1 ohm would be same as current passing through this
So
hole.
the 2 ohm, yes. So the 9 ohm and 3 ohm is in parallel.
Hmm. So we can directly write it. I'll
No,
just,
ma'am. We had to that find current using the current dividing rule.
how we can do that? Give me a minute. Okay, so we can write
Using the
on.
we can find that point, that A point and B point, they are connected in parallel. 9 ohm and 3 ohm.
Yes. We can now apply the current divider formula.
Yes.
So current divider formula for this 3 ohm. So it would be this 9 ohm multiplied by this current, and this addition of 3 ohm.
9 plus 3.
Yes. So we will get 9 ohm into 2 ampere divided by 9 3 12. 2 6 are 12. 3 2 is 6. 3 3 is 9. So we are getting 3 by 2, which is 1.5 ampere.
Yes, ma'am.
Is this okay?
Yes.
Okay. Now in the here. Now in this last question, it is asked the voltage across this V naught. So if you see in this first question, the current was in this direction, So if we take the direction of current as I, so here we found the current as I is equals to minus 0.5. There is no direction given earlier, that's why it was 0.5. But if we take it for this last question, we are taking this I going from here to here. So this is minus 0.5. And if this is not clear, I can do by the different method. And for this question, we took the direction as this. So here I would be positive 1.5. So
Positive 1.5.
so
Yeah,
the
like
whole say
using the because 17.2 is given the
yes.
that so
Your voice is breaking.
so power. No, we had to find a current only. Yeah?
We can like find it like this. We have R, which is 1 ohm, into I, we which we found 1.5 minus 0.5. Wait, I should write this in a correct form. So let's take this I. See, this I convention is we are only taking it for this last question. It's not for the first one and second one. So from this, we will get I x1 as minus 0.5. Why? Because this 1 ampere was coming here and we took the current direction in this way, but current was in this direction. Is this thing clear? Is this clear?
Yes.
Pakka wala? Like if you it is not clear, I can explain.
Yeah, it is clear, ma'am, because of 1 ampere is in opposite direction of that 2 amperes. So from over 2 ampere we got 1.5, and using the 1 ampere we got a 0.5. So it will be subtract from it. So we will get 1 ampere.
Yes. And now in this one, we are getting the current direction is in the direction we assumed. So that's why it is plus.
You are
So
talking about that question. I am thinking that you are talking about 17 point. Sorry. Okay. So yes, ma'am. Due to magnitude, I confused. I don't know what what positive or
uh,
negative I mentioned in that answer.
okay, see, this whatever we did was for these questions. So there was no convention of current was given, which we have to find for this 1 ohm.
Okay.
So whatever we wrote the 0.5 and 1.5, that's correct. Okay.
Okay. So
Now we are
only
taking.
because I confused only because of the magnitude word is used in that question.
Uh, wait, so magnitude is just simply this 0.5. Na? If there
Okay.
would be something complex current or something like this, then we can talk about the magnitude and all.
Okay. Okay.
Oh yes, and the one thing that is given that magnitude of current. So even if it is turning out to be minus, you will write it as 0.5 simply. Like the minus sign and plus sign is not mattering here.
Okay.
Like they have asked this. So if we have to write in this one question, so we'll take this magnitude, means this will simply turn out to be 0.5. That thing.
Yes, ma'am.
Okay.
Because here only asks for the current, or did not ask for the absorbed or delivered powers.
Yes. This minus sign we are only taking it for this last question because that will just make it easy for us.
Yes.
So this is I. We are taking it. We are assuming it by ourselves for the 7.17.3 question. So we took it in this direction.
Yeah.
So Ix1 is minus 0.5 because the current was flowing in this direction.
Yes.
This direction, and we
Yeah.
assumed the current in this direction. And here the current was flowing in the same direction as we assumed. So that's why it is positive. Okay.
Yes.
And now when the both are on, we will get I is equals to Ix1 plus Ix2.
X2. Yes.
So it would be minus 0.5 plus 1.5, which
Yes.
is 1.
1. Yes.
And now we have to find the power in, we have to find the voltage. So V
Voltage.
naught
Yes.
would be R
V
into
is
I.
equals to I upon R.
So R
I
is
into R. I into R. Yes.
1 ohm
1
and
into 1 ampere.
so this will be 1 volt.
1 volt. Yes.
Is this correct? Is this clear? All the questions? Is this clear to everyone? All the questions? Any doubt?
No, ma'am.
I
Ma'am,
think
when we will start the week 9?
it will start from the next session.
Okay.
And hope this question would be clear to everyone also. I was doing it wrong. It's
No, ma'am.
okay.
Clear, ma'am. Thank you.
Okay. So, should I stop streaming? Stop presenting?
Yes, ma'am. You can.
Okay. Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, madam.
Bye bye.